Okay, I think it's 12:20 on the dot. Welcome everybody to this HDF clinic. Any questions? That's what this is all about. So for all of you who joined, are there any questions about anything related to HDF5, HDF, anything? No? Okay, well then, okay, then anyway, feel free to interrupt me at any time should there be any questions. Okay, so as my default topic, I picked HDF5 and open science because it's important. Pretty much any agency has a open science related initiative. And it's a very interesting topic. I mean, we want to serve our users as best as we can, and open science is an important part of that. And so what I tried to do is just sort of collect a few thoughts about the role, the contribution that HDF5 has made to open science already, and where I think there are opportunities, and one specific opportunity to make an even greater contribution. Okay, I'm not gonna, so this is all on GitHub. Most of you probably know that in the HDF group GitHub account, there is an HDF clinic repo, and sometimes if people have material they want to share, they just put it under the date. So today's date is the 11th of February, and there's a markdown document and a picture that is down below. And yeah, so it's all together. And here's the outline. So we'll talk about not too much about open science, HDF's contributions, what we mean by open science being networked science and what that means for HDF5. And then specifically, I want to talk about some interesting, I think, synergies, to use a strange word, between knowledge graphs and HDF5. And I'm going to give you one specific use case that probably is applicable in many areas of science and open science, and then also leave everybody with a few references to Python modules that might be helpful if you want to do experiments in this area. And then, but there are also some non-Python tools like online services and so forth. Okay. Let's get started. So I'm not going to spend much time. I kind of assume that everybody knows by now what open science is. All I'm going to say is when I heard the term open science years and years ago, I first thought that was a very odd way of calling something open science. My only reason is that it feels a little bit that, yeah, as I say here, putting the cart before the horse, because in my opinion, it puts a lot of emphasis on the means of something to achieve an end, but that end is really, as this is a very nice book here called Reinventing Discovery, that really, that's what it's all about, that today, for a variety of reasons, we have the opportunity and the technical capability and so forth to tackle a new class or new classes of problems. And on the way to solving these problems, some of these open practices, whether it's open peer review, data sharing, and all the rest of it, these are sort of means to an end. But then this is what people call nowadays open science. And as a scientist myself, by training at least, I always thought that science was open. So when I heard the term open science, I thought, what's that all about? And so anyway, now, HDF5's contributions to open science, well, there are quite a few, and I'm not going to go through them in detail because I think most of you will be more than familiar with that. So this idea of sharing data across platforms and environments indefinitely, that's pretty much at the core of HDF5 and has found its way into open science practices. So the contributions include the interoperability and standardization that HDF enables, the efficient handling of large and complex data, that there's a tremendous open source ecosystem that has developed around HDF5, that people have achieved a high degree of reproducibility and transparency by storing many of their important research data, whether it's experimental data or simulated data, in HDF5, and then our commitment to data preservation and with our forward and backward compatibilities, I think we've made an important contribution and continue to make an important contribution to long-term data preservation. And it's been broadly adopted. Look at Google Scholar, look at your favorite source that lets you estimate the popularity of HDF5. You will find that. And there are many sources where you can get help, domain-specific help or general help in HDF matters, and these are all great things. Now, what I said earlier, in particular, when you read this book, this is actually a very Reinventing Discovery, very nice book. The author keeps pointing out that open science, first and foremost, is networked science, or that behind this idea of reinventing discovery is the ability to access pretty much everything, whether it's services, data, have exchange, blogs. That network is kind of a necessary condition of that. However, if you think about it, well, when people say HDF5 data is available on the network, they typically mean different things, and I just picked four. Very simplistically, you could say, okay, if I have on an NFS volume, I have a few HDF5 files, technically within like a Kerberos realm or something like that, you can access these files remotely, and that's over a network. You could be more sophisticated and have a deployment of like HSDS, the highly scalable data service, call it HDF server. So you would have a RESTful endpoint, and that would be HDF data on the network. Another thing would be there are all these nice repositories out there, such as Zenodo and Dataverses, and you can deposit research data, and a lot of research data is actually being deposited there every day. And you could say, okay, that's HDF data available on the network. And finally, you could also have a situation where there are public data sets, for example, available with large public cloud providers such as AWS or Azure and so forth. They have these public data places. And you can put HDF5 files there, you can put cloud optimized HDF5 files there and so forth. All good. Okay, so it looks like there are a lot of technical solutions for different use cases. And in my opinion, however, they all share a common problem. And for the lack of a better metaphor, I would call this, remember the days of the internet without search engines and semantics, meaning that for a particular use case within a particular realm, this sort of depositing HDF data in one of these, in double quotes, silos, and I don't mean that in any kind of derogatory sense, but by placing them in a closed world, if that's your natural habitat, or where you perform your services or how you interact with the data, that's all good. But just picture someone who might actually benefit from that data, who might want to access that data. How would they find out that that data is there? And once they found out about it, how would they get access to the data? Do they need a specific client, such as Globus? And then do they have to download, for example, large HDF5 files pretty much wholesale, or can they take advantage of partial I/O or something like that and just request a subsample of a data set, or first review attributes of certain data sets, or get something like a JSON digest of the structure of the whole thing? So I think that's where many of these solutions fall short. And then you could think about, well, what would we do? What could we do to overcome this siloed distribution of data? And this is not a new idea. The idea of knowledge graphs is perhaps as old as the semantic web. So back in the early days of the internet, the early 90s, when Tim Berners-Lee was working on early forms of the web at CERN, there was from the very beginning this idea, okay, making HTML pages and things like that available and designing the HTTP protocol. That's all good, but then how do we give meaning to the data? How can a client understand what that data actually is about, and so forth? And so that they created things like the Resource Description Framework, RDF, where you can record assertions or statements about certain entities, and it has a very simple sort of predicate form where you have this SPO, subject, predicate, object, type expressions, and you just can, or some people call them triplets. So there's a whole zoo of triplet stores where you can then query them using a query language such as Sparkle, but then there's also Neo4j, and also there are many good options. And so these knowledge graphs, and there are knowledge graphs that are sort of public, and we'll see a few examples in a moment. So these are open knowledge graphs that have a model like Wikipedia, where everybody can contribute statements or assertions to these knowledge graphs. But then, of course, for like for an enterprise or an organization that needs to tightly control the generation of knowledge and the curation of that knowledge, then people sometimes speak of enterprise knowledge graphs, for example, where there is access control and but both forms, the technical underpinnings, of course, in both cases are very similar. Now, what would that buy us? Well, we would not use these knowledge graphs to actually put data there. So these knowledge graphs, they do not replace the Nodo. They are not going to replace a Dataverse or an HSDS endpoint and so forth. The data still has to go somewhere, but these knowledge graphs act as, some people sometimes call this like a semantic data fabric, where you can pretty much start anywhere on these knowledge graphs. So you can, we'll see an example in a moment. You can just search for something that's of interest to you, and then if you traverse this knowledge graph, that pretty much means you are discovering related information. So, for example, if I were to look up HDF5 in that in Wikidata, for example, I could discover tons of publications that take advantage of HDF5 in some form. I could also discover something about the HDF group. I could discover something about library releases and so forth. So all as you enter this knowledge graph, so to speak, you can then exploit the graph structure to navigate your way around and discover related information. And that is actually the simple reason that you can then sort of transcend, if you wish, these silo barriers that, speaking of HDF5, would separate if there is a collection of a certain type of data, whether it's geospatial or something like that, and then you have maybe material science data in a different silo, then without a knowledge graph, well, yeah, these are just two separate entities that are, where there is no bridge between the two. And whereas in a knowledge graph, as part of a thesis or as part of something, and I'm not saying material science and geospatial are sort of natural neighbors, but there could be a scenario in which where there is a connection between the two, and then if that were captured and expressed in that knowledge graph somehow, then it would be out there to be discovered and taken advantage of by all users. And so I just, again, I'm not going to go through all of them, just trying to highlight a few of the benefits that would come from complementing HDF with knowledge graph, enhancing the metadata provenance tracking, interoperability across repositories and tool, advanced search and discovery, a lot about fair, findable, accessible, interoperable, and reproducible practices around data management, reproducibility, data provenance, and then finally, community platforms and tooling. This is sort of, you can write very, very much more featureful applications where, when you fire up the application and the user does something, the first thing is you kind of, we reach out to that knowledge graph and see, well, let me see what's out there, and then on demand access perhaps some of that, some of the actual data that's being referenced, and then visualize them somehow or summarize or all kinds of good things. Which brings us to use cases, and there are many use cases, but I'm gonna pick one. And the one that I'm picking here is that right now in sort of AI type applications, this retrieval augmented generation is a very much a hot topic. And the question is, well, how could that help with HDF5, or how would a knowledge graph help with that? Well, these RAG, as they are also sometimes called, these RAG tools have kind of two components. You can think about it like that, where there is a retriever component or a retrieval component and a generation component, which is typically a large language model. And the way that, without that retriever, the LLM is kind of frozen in terms of its knowledge, frozen in time. When it was, let's say it was trained in 2022, well, that's the knowledge that it has in 2022. Anything that happened in the meantime, that LLM, in double quotes, doesn't know anything about. And but with this trick, if you wish, by injecting a retriever here before actually presenting a context to this large language model, if you retrieve current information, then you can present your user with much more relevant, perhaps, and updated, most importantly, information. And so the way this would work, so many of you have probably used ChatGPT or some of these other tools where you can upload a PDF file or a Word document or something like that. But then another way of sort of triggering a retrieval process would be to contact a knowledge graph. And that knowledge graph could be, I listed two public knowledge graphs here. Google started very early developing their knowledge graph. And when you do a Google search nowadays, sometimes you get this sidebar where there is, depending on what you are looking at, you find additional information. Like, let's say you were looking for a movie, it will give you something about maybe how successful it was at the box office and the cast and things like that. And but then another one, and if we'll have time, I'll show you a quick example from the Wiki Foundation. Wikipedia, of course, everybody knows Wikipedia. However, they also maintain the infrastructure for this public knowledge base or knowledge graph called Wikidata. And so that retriever could contact this knowledge graph. And then let's assume I'll talk a little bit about, or that's what I would like is make that connection between the knowledge graph, store, if you wish, facts or assertions about HDF data that maybe lives in Zenodo, that lives in Dataverse or in one of the data access centers, or I listed here, this is the NREL HSDS point for the wind data set, for example. So how would that happen? Well, I listed here this, if you click on this link, that takes you to Wikidata. And so this is it looks like a web page, but it's really a rendering of a set of statements about this subject. And I mentioned earlier, well, these statements are always of this simple subject, predicate, object form. So in this case, the subject is a sort of the identifier that Wikidata uses for its subjects are these Q identifiers. So it's always Q and then some kind of an integer. So in this case, this is one of the data sets curated and created by NREL, by the Department of Energy. And so this is in this case, a wave hindcast data set for a variety of geographical regions. And so there is a little bit of a synopsis here, a description, and then here it says statements. So now I'm making these assertions. So for example, one assertion that we are making here is that, yeah, this subject Q, whatever, is an instance of a data set. And then you could click on this and try to look up, this is another entity, something that can be the subject or the object of these assertions. You can look up, okay, how do they define what a data set and so forth is, but I'm not going there right now. But then you can record other statements such as, okay, where can I find a description of that data set? And here they have, for example, there is a GitHub repository in the NREL account where they describe, okay, what's included in this data set, in this wave data set, and there's a description and it mentions publications, information about the model. This is mostly for human consumption. What's important about Wikidata, and I should have mentioned that earlier, when we talk about that open science is fundamentally network science, what is important is really that it's networked for humans and computers. This is one of the critical things about open science, that we will, in a way, be able to make these qualitatively greater discoveries only if we can enlist, in double quotes, the help of computers in the scientific process. So all that data must be interpretable and accessible by humans and machines. And so these knowledge graphs are, of course, accessible by machines, and they are interpretable by machines in the sense that if you have a subject like this, for example, well, based on the assertions that are made about this particular topic, you can, in a way, in double quotes, understand, you have a context that tells you, okay, this is about a data set. This is not about, let's say, this is not about a food item, or it's not about a municipality, a specific municipality. It's really through these statements, by parsing these statements, you have a context that then defines, in a way, what the meaning of the underlying or linked data is. Okay, here's a publication described by source. So most importantly, talking about this, creating that link here. How do I come from the knowledge graph? How do I get from the knowledge graph? How do I get my hands on the data? There is a connection here. So in this case, for example, we know that this data is hosted by HSDS. And so here is the, as John Reedy would call it, the domain where this data set, or these data sets, they're actually multiple, are hosted. And then we have a qualifier here where we say, okay, by the way, the content delivery mechanism is HSDS. So to a machine agent, this should be kind of a telltale sign that says, okay, if you want to get a hold of a specific data set from a specific HDF5 file, well, you better, let's say that's written in Python, you better load up H5PyD, and then you just connect to this endpoint with H5PyD, and from there, it's just like H5Py. So you can look at the available HDF5 files, you can look at the data sets in there, and all the rest of it. You can find attributes and so forth. And then this is just a sample record, but as you saw earlier in that description here on GitHub, it lists all the regions, if you wish, or the HDF5 files for the respective regions. And I just took the first one. So if you take this one for Alaska, then there would be, for the full collection, there would be multiple parts, but I picked here just the first one. So I'm saying this HDF5 file, Alaska_wave 1979, .h5 is part of this collection. And now I'm going to traverse that link by, of course, this is another entity in Wikidata. So it has this QID. And here are statements about this entity. So in this case, I can say not only is it a data set in the abstract sense, it is actually an HDF5 file. And this is, by the way, a logical HDF5 file. Whether it's a physical HDF5 file doesn't really matter very much at this point. But yeah, I'm just setting the tone, or for the client, if the client is a machine, to say, okay, you got to understand what how to deal with HDF5 files if you want to access that data. It's part of that greater collection, so there is a bidirectional link here, in the sense that the overarching collection, the object that represents this overarching collection, has links or pointers to its parts, but then the parts, of course, refer back to the parent collection, so to speak. And yeah, it's part of this data set. It has a title, there's a location, point in time, and things like that. But then here's again, we are talking about HSDS as the delivery mechanism. And this is the endpoint that you would use with H5PyD, for example. And then here you could say, okay, now I want to go into this domain. And if you had H5PyD, all you would need is point it at this endpoint and then discover, well, what are the variables that are stored in that domain, and how are they structured, what are their data types, and all the rest of it. But here there is sort of some flexibility in the knowledge graph. You could say, well, rather than asking someone to go there and discover that, why not be a little more user-friendly, a little more usable? And here, for example, I think there's a total of about a dozen variables in this, and I just picked 3 of them. So for example, there is a data set in there called significant wave height. There is a coordinates data set. There is a directionality coefficient data set. So I can then continue from here, and if I'm interested only in the significant wave height data set, again, I can sort of discover information about that. And then here, talking about identifiers, you actually see an S3 object identifier. You can actually, go there directly. This is not a tutorial on HSDS, but this is just to give you an idea. This is how you could make this connection from the knowledge graph to actual data stored in HDF5, and then this retriever, should that be necessary, could actually pull in that data and put together a context and a prompt for the actual generator. Now, this is of course highly mechanized already. So I just listed, if you want to work in this space, there are a few interesting Python modules, most notably RDF5, that's sort of, to deal with these triplets. This is a very convenient way if you want to also create your own ontology or something like that. That's a convenient way to do that. Then just do RESTful requests against these knowledge graphs. These knowledge graphs, the public ones like Wikidata, but also the Google Knowledge Graph, they have RESTful APIs. Then your favorite large language model goes here. And then if you want to interrogate this knowledge graph, find some interesting leads and so forth, there's a module called Sparkle Wrapper that lets you run Sparkle queries against a knowledge graph, and then sort of the usual ML modules. Finally, there are, so for example, if you just want to practice a little bit with Sparkle, for example, there is a Wikidata query service here, so you can really type in and retrieve results from Sparkle queries. So this is like a sandbox or a playground. There are also, in Wikidata, they have a concept of a schema. If you would like to, if you are looking for, from a graph perspective, nodes that have a certain local structure, meaning you are looking for statements of a certain type. What do I mean by that? Let's say you are looking for a researcher. And of course, then the question would be, well, what do you mean by a researcher? Well, a researcher would probably be someone that is a human that has an occupation, for lack of a better term, called researcher. And maybe that researcher would probably also publish articles, so they would have an ORCID ID or Scopus ID or something like that. So in that schema, you could then say, well, I'm only looking for nodes, for subjects, for items that are instances of where the following are true. There is a statement to the effect that this is a human. There is a statement to the effect that their occupation is researcher, and that there is something like a ORCID ID or a Scopus ID or something like that. And then, so with these schemas, they go sort of both ways. One, sort of in a filtering capacity, but also if you are, let's say, a curator, because we haven't talked about that yet, but as with everything data, data quality is important, and garbage in, garbage out, and knowledge graphs are no different there. So if you want to really create large knowledge graphs, you are well advised to very early on think about how you are going to curate and maintain a level of quality of your entries, that they are consistent and accurate, and sort of all the usual data quality criteria apply here. And there's also a playground to play with these schemas. These are called shape expressions. There is an online validator where you can just retrieve something, a set of items from the Wikidata knowledge graph, for example, and then you have a schema, and then you can say, well, which of these items actually conform to this schema. And then, yeah, Kaggle has some interesting collections. So time is up. I'm happy to answer any questions. I really want to write some proposals and do collaborations in this space. So if you are interested, email me. Here are a few references, and then just sort of for the nerds, just last week I did an interesting experiment. So one of the later ChatGPT models, O3 Mini High, was able to do the following. Remember, in our BNF description, if you scroll all the way to the bottom here, there is sort of a Mickey Mouse example of an H5 dump output. And so ChatGPT O3 Mini High can do the following. You can prompt it and say, can you write me a C program that, when I run it, produces an HDF5 file whose H5 dump output looks like this. And it was actually able to do that. The code compiles just fine, and it's almost right. There are sort of two interesting mistakes in the program that it makes. There is a variable length sequence data set in there, and the first element is wrong. It's the empty sequence rather than the sequence that contains 0. And then there is a second interesting mistake that it made, which is that in the example, the in-file data type is big endian. It's floating point big endian something, and it's just a little careless there. It makes the in-memory type also big endian, which of course on the little endian architecture gets you into trouble. But other than that, I was impressed that it could do that, because I remember I did this maybe a year ago, and the thing didn't even compile. So there's a lot of progress, and it's exciting. Okay, questions? Anybody? No? Okay, well, let me know. Send me an email if you have follow-up. Please get in touch. I think this is a very interesting area, this sort of, yeah, doing linked data, you might say, for HDF5, because I really think for many scientific projects where you want to bring different kinds of data together, and yeah, the idea that people will create these super collections where they copy data from everywhere and bring it together in one place, that's just naive. It's not going to happen. So then the question is, well, okay, the data has to stay where it is, but then how can we, or parts of it rather, how can we dynamically bring relevant data together to sort of feed these retrievers, for example? And I think knowledge graphs at the moment are one of the technologies that I can see is definitely capable of doing that. And yeah, so that's very interesting, I think. Okay, cool. Well, thank you very much for coming. Come back next week, next time, and have a wonderful rest of your day.
Great. Thanks, everyone. Bye.
Thank you.
Thank you.